from Sjoerd is enough? Yeah. Okay.
Yes.
Perfect. Okay. Perfect. Then people are still joining. I hear it in my my ear the sound all the time, but it's time. So let's get started with the webinar. Rule-based customer success versus AI-based customer success. So first of all, hi everybody. I hope you're all doing well. My name is Maarten Doornenbal, and I'm one of the founders of Churn. Together with me is Sjoerd van de Beukel. Sjoerd is a data scientist at Churn, and together we will be presenting the webinar of today. Also, on behalf of the rest of Churn, we would like to give you a warm welcome, and we're very happy that you're here today. Just like last webinar, where we started with an icebreaker, we would like to do the same, but with a different question, where we would like to ask you the question, who of you is already using AI for their customer success efforts within their company? So you can see the answers in the screen. So option 1 is yes, I'm already using AI within customer success. 2 is no, I'm not using it and not consider using it. And 3 is not yet, I'm not using it yet, but I'm considering using it. Sjoerd, would you mind muting yourself for a minute? I hear some kind of echo. So please share your answer in the Google control panel. And very curious for your answers. I cannot see it because I only see my screen, so that's a bit unfortunate, but we will go through it later on. So then the topic of today, we will be comparing rule-based customer success with AI-based customer success. And many of the current customer success solutions follow a rule-based method in predicting customer health and following simple rules. And only a few of them are already using more complex AI for this. And during this webinar, we will try to look at the differences between both methods. What are the benefits of both? What are limitations? How are they different? And how can one method overcome the limitations of the other method? Then for a matter of housekeeping, a recorded version of this webinar will be available following the presentation. And of course, we would also love to hear from you. So if you have any questions, please use the chat function below to ask your questions. And we will go through the questions at the end of the presentation in the Q&A section. And my colleagues Brendan and Mus are also here. They're monitoring the chat, so they will come up with the questions once we're there. So then, the agenda of today, welcome we did, then a little bit about us. Who are we? What do we do? Then I will be presenting rule-based customer success management. What is rule-based CS? How is it used? What are the benefits? What are the limitations? Sjoerd has a more technical background and will explain the AI part of CS. So what is AI? How is it used in CS? What are the benefits? What are the limitations? Is AI capable to take over part of to overcome the limitations of CS? We will then try to conclude it by answering the question, what will be the future of CS? Will it be AI-based? Will it be rule-based? And then we end up with time for questions in the Q&A. So who are we? We are Churn. We are an AI customer success management, retention management platform. We've been founded in 2019, end of 2019, by a professor in data science, his former student, which is also my brother and myself. We are based in Amsterdam and serving international clients, and we're mainly used by customer success management teams and marketing teams. And in line with the topic of today, we follow an AI-based method of predicting customer health. And by that, we think that's the real data-driven method, and which is not rule-based. And how we do it is by bridging the gap between complex machine learning and AI and customer success management, and transforming your customer data into accurate predictions for churn, health, customer lifetime value, engagement, and not only predicting, but also coming up with actionable workflows and solutions to prevent churn or increase engagement and CLV. And we are we're serving great clients, including some of the companies that you see here: ITRS Group, Mercell, and Ginzy. Very happy with them as clients. So then, rule-based CS. Still hear people joining in my ear. That's good. Rule-based CS. I think that we can state that customer success tools and platforms have really been a game changer for SaaS companies. A CS platform unifies all customer data into one single dashboard and enables a customer success team to proactively engage with customers based on their health and their behavior. So the customer data comes in from multiple sources. They're integrated in the CS platform, and then the data has to be processed to transform it into actionable data. So for many of the customer success tools, a popular way of processing this data within the tool is processing the data to predict, for example, customer health, is with the rule-based systems. And rule-based systems use an if this, then that structure to take known information, to process that, and to develop a result out of that. So if we want to define it, we can define it as follows: a system that applies human-made rules to store, sort, and manipulate data, and by doing so, it mimics human intelligence. So why would you choose a rule-based method? Because of course, the companies that do it, they're not doing it wrong. It's actually, there are definitely benefits of a rule-based method. So let's go through them. And one of them is complexity. So rule-based systems are not very complex, and therefore they're relatively easy to build. And in customer success, the rules are stored in the CS platform, where they can also be modified by a customer success manager, by a business analyst, without any programming knowledge. So in that sense, relatively not complex if you would compare it to an AI, where of course programming knowledge is required. And also regarding the complexity, it's easy to understand and interpret, hence creating trust within the organization and the people that will make use of it. And then last, it can be built in co-creation within the different business teams, and they determine the hypothesis and how the applications work together. So then, how does it work? Here you see a visual that I made. Very proud of it. So for a rule-based system to work, you require a source of data and a set of rules to manipulate that data. So these rules are set by humans and are sometimes referred to as the if statements, as they follow the if X happens, then do I line. And you can see in this example how that would look like into practice. So on the left, you see the sources of data. Here you can see it's HubSpot, Mixpanel, and Freshdesk. And for an CS, it's of course an important source of customer data is often the CRM data. So in this case, we use HubSpot as an example. Then a very important source of data is the usage data, often a very important predictor for health in SaaS. And the usage data is here tracked in a tool Mixpanel. And then in the third, you can see the source of data is the support tickets, which are stored in Freshdesk. So these three tools are here in this example integrated into the CS platform. So they contain all the facts and the data of the customers. So then comes the analysis part. That's the part where the system conditionally processes the data against its rules. And in this example, you can see the rules created by the customer success manager. They are on usage, on contact, and on financial. And so the if statement here is that if a customer logs in more than 50 times a day, did not raise a support ticket in the last 30 days, and has his invoice status on paid, then the customer health is good. So we got the data, it comes in, goes conditionally processed against the rules, and then the subsequent automated follow-up actions come out. And this can be both a human performed action as a automated action, like having an onboarding call or sending them a nudge through the application. These are examples of CS actions, which you're probably all quite familiar with. To end this slide, so going to the limitations, you can already see one of them listed here. So you have a lot of data points in the systems, in your three systems, and the CS manager makes a couple of rules, which maybe only make use of 150 of these data points, which of course, maybe leaves you with a blind spot. So mentioned the benefits of a rule-based system, but there are clearly also limitations of that. First of all, it uses subjective human-made rules to predict. So partially based on gut feelings, rules are based and also alerts are set. Then another important limitation is that rules need constant human input to adjust and to improve. So for example, if you have a SaaS product and you update the product with a new feature, then the old rules become out of sync. But it can also be the case that your customers might change in behavior, for example, because they mature over time, which also require you then to constantly calibrate the rules to be in sync. Then a third limitation is the human capacity to get the right information out of all the tons of information. And that's actually the example that I showed in the last slide. So you have hundreds or thousands of data points and variables. It's almost, or it's nearly impossible for the human mind to complement, to analyze, to correlate, and to configure accurate rules for account health and alerts. And also because of this, and that's also shown in research, that only 1% of the data points is often used to determine the health, as showed in the previous slide. So it might leave you with dozens of blind spots that are blocking you from being proactive. So even when you have all the right data in the systems and you have a great platform to process that data, there's a risk that if you don't, that you will never get an alert if you don't set up the right rules because of that. And then lastly, yeah, rules don't work on exceptions and exceptional cases. And I think that practically every company has exceptions and exceptional cases. And in the next part, Sjoerd will try to explain AI-based customer success, so the benefits of it, the limitation, and also if it's possible to solve a part of these limitations for rule-based. So here you go, Sjoerd.
Thanks, Maarten, for the clear explanation. Well, I'm Sjoerd. I've worked the past few years as a data scientist. I'm specialized in developing and applying machine learning systems on customer loyalty problems. And today I will introduce AI-based systems for customer success management. Well, many of you probably heard the term AI or machine learning quite often, but are still wondering how these systems work. Well, an AI system is designed to define its own set of rules based on data outputs it has access to without human intervention. Well, this indicates that the difference between a rule-based system and an AI system boils down to who sets up the rules. Is it the computer system or is it the human being? Well, this works in a way that the system can set up these rules based on patterns it can recognize in the data. Well, how does it recognize those patterns? Let me give you an example. Let's say we have an account manager at a software company that wants to target his customers for potential upsell. He has data for over the past 2 years, and he wants that the AI system returns the customer that is likely to accept an upsell proposal. What the system is then going to do, it will take the 2 years of data, it will split the first 20 months from the last 4 months. It will use the first 20 months to learn and recognize patterns that correspond to someone that did an upsell, that accepted the upsell offer. And it will compare the data to people who didn't. So it will split the data in 2 groups. Then we have the upsell candidates that accepted and didn't accept. And it will take for everyone the moment of upsell, and we'll then look at the data, what happened right before that moment of upsell. And it will look through all the features, and will take all the data into account, and will see which customer segments and which customer behavior correspond to someone who didn't and did accept the upsell offer. And because machine learning is so good in splitting the groups on a very deep level of customer segmentation, it can achieve a very high accuracy. It is, for example, able to retrieve relations that it can see that a customer that is there for over 3 years, that is located in the city and have around 14 logins a week, is very likely to accept an upsell offer. Instead of a customer that's only there for 2 years and lives outside the city, but has only 7 logins, is also very likely to accept the upsell offer. And because the machine is able to break down the data in so many segments, it can retrieve a very accurate prediction. And all these patterns are retrieved from that first 20 months of the data. Then the last 4 months are used to make predictions. And because the last 4 months have already passed, you can check what the performance is of your machine. In this we call the test phase. And in the test phase, we are able to tell how well can we predict the metric we want to predict. So based on past behavior, an AI system is able to extract patterns. These patterns reflect the rules in the system, and these patterns are based on a probabilistic approach. So it will recognize all the patterns that hold for most people, not necessarily all, and it will then set up the rules in such a way that it retrieves an optimal outcome. It will retrieve that the most people are predicted correctly. Well, now we know how an AI system is able to set up its own rules. Maarten, can you go to the next slide? Well, how does an AI system look then in practice? In practice, an AI-based CSM system will look as follows. So we have the different data inputs. All the data inputs are connected. So this is usage data, contact data, marketing data, and financial data. You all connect that to the system. Then the system will take all the different data sources and will retrieve features from the data sources. And one of the benefits of machine learning is that there's no limitation in the amount of data. So it will be able to combine all data and connect it to the system. This is provided to the AI learning phase. And in the learning phase, the AI will recognize patterns that correspond to certain outputs. Well, in customer success management, it's useful to have an application that can predict a call to action. So it can solve a question like, who of my customers need attention in order for them to keep getting value out of their subscription? Well, the AI system will learn how to use specific actions to keep the customers happy. It is then able to predict on a customer-specific base whether an action is needed, which action is needed, and when this action is needed. And in practice, the machine will be able to give the customer success manager an alert when an action of them is needed. In this way, the AI and customer success manager cooperate in order to make the customer happy. Well, the machine will then feed the actions that are taken back to the AI learning phase, and where it learns then again from the outcomes that the new actions brought. And because it can take that continuously into account, it can retrieve new and better actions. So in this way, it continuously develops and improves its own predictions. Well, now we know that how this system can be used by customer success managers, but what are the advantages of the AI system? Maarten, can you please go to the next slide? An AI system can outperform a rule-based system on a few aspects. It can achieve a more accurate prediction than rule-based systems because it can use unlimited features of all data sources, and it is even able to combine all features. So therefore, it's able to extract more complex relationships, and because it can handle more complexity, it can cover more edge cases, where in rule-based system, every edge case needs a bunch of new rules that needs to be set up by some business experts. For the machine, it doesn't require extra work. The AI will do this learning for you. And because machine learning will set up the predictions in such a way that the outcome variable is optimized, there's no space for human bias. Another big advantage of the AI system is that when an AI system is set up, it's very easy to maintain. This is because an AI system is able to continuously learn and adapt to new patterns in the data. And it learns from the actions taken, and will improve new predictions by taking those actions and outcomes into account. And furthermore, when the product is updated or new data becomes available, it's very easy to add this to the model. The only thing you need to do is or add the new data source to the system or add a product update in a new feature, then the AI system is able to retrieve this new data, extract new relations based on this new data, and come with new and better actions to predict. This again doesn't need any human intervention. On rule-based systems, when a product update is done, it will require a business expert to set up new rules that can take into account this new data. But of course, machine learning also have requirements. One requirement is that an AI system requires data. You should have information about the desired outcome variable and about the actions that can affect this outcome. But there's often a misconception that this directly indicates that someone needs millions of data points. Well, this is not the case. There is some data needed. Even when there is not a lot of data, AI systems have methods to handle this well. Thereby, it should be kept in mind that rule-based systems that are company-specific also need to take data into account. Well, for these systems, it could be beneficial to use AI instead of rule-based. Second, an often heard argument is that companies don't have the knowledge about AI and it requires to hire a team of skilled data scientists to set up a system like this. Well, there are also tools for this. The Sjoerd is one solution of making complex AI accessible to a wider public. And in this way, you can retrieve, you can get the knowledge inside. Well, I think these points best describe an AI-based system. And eventually, most customers choose to use AI system based on that the performance is more accurate than rule-based. For a lot of companies, that is the reason to incorporate it in their CSM strategy. Well, Maarten, I think this explains the AI-based system.
Yes. Then to wrap it up and to come with the question, what will be the future of CS? Will it be AI or rule-based? So first of all, as a customer success manager, of course, your goal is to get to help your customers get the most value out of their product or their service. And in order to do so, you need data. So data really helps a customer success manager in achieving this goal. And that is also why we believe that the future of customer success is going to be grounded in data. But so as we just discussed, a rule-based system limits your CS team of making best usage of the data, and that is where the AI comes in. So less blind spots, accurate predictions, and less firefighting. But as we also discussed, AI is very complex and not easy to build. However, also just like Sjoerd mentioned, it is possible to overcome the complexity limitation of AI by using a specialist solution like Sjoerd. So you don't need a technical in-house team, technical know-how, or many years of development, because that's of course what it requires to have a good product. To be able to use AI in your CS department. Does it mean that CS should be approached completely based on tech? We really believe it's not the case. Humans are of course very good in building relationships, and this is a crucial part of CS that cannot and should not be replaced. So we think that the most powerful combination is an AI-based CS platform that is complementing human efforts. Also because AI is very good in seeing which human efforts can be deployed when and where. So we believe that human plus AI will be the future of CS. I hope this was clear and it has given you new insights. It's time for questions. So Mus and Brendan, did we receive any questions? And if so, you can kick off with one of the questions.
Yes. So the first question that we actually received was from Skip. Skip asked, what is AI-based systems' ability to tell which inputs yield which outputs? And I think this question has to go to Sjoerd.
Yes, thank you, Mus. I saw the question. This is an often asked question. So what the AI system does is that it can combine so many features that for us as humans, it would make sense to translate it back into rules and specifically say what caused a certain output. There are methods to retrieve which of your input is important for predicting. We can retrieve general rules out of the system, but we cannot exactly say what caused the output. And this is because what I just told, that machine learning can combine all features of the data, and the relations are not as simple as one-on-one, and therefore the rules become too complex. But it is able to see what of your input was important and had a high predictive power.
Okay. I don't see any message that complains about your answer, so I guess that's clear for Skip in that sense. And then there was a second question from David, actually. He asked that he noticed as a CSM manager that he notices whether his clients are happy or unhappy based on his meetings with them. And this is a human interaction, obviously. So how is AI handling this problem?
A few of the companies I worked with also had this problem. And the sentiment a customer success management manager can notice after a meeting can be a very good indicator about the happiness of a client. And the systems I worked with, we introduced a sentiment indicator in the CRM or CSM tool. And this was an indicator of a score from 1 to 10 that represented what the sentiment was of a meeting. So after the meeting, the customer success manager could give this a sentiment score. And because then that was transferred to data, this can be fed to a machine learning model. And the machine learning model can then take this into account. And what will happen, the machine learning model needs to choose, is going to see whether it is an important variable, yes or no. When it's indeed important, it will recognize it and it will give a high weight in the predictive power of this feature. When it's not important, the model will throw it out and it will not be used. But then you also have that insight. So in this way, you can still use machine learning in combination with human input. Is that answering the question?
I see nothing from David anymore, so I guess it did. Great stuff, great stuff. Are there any more questions from the ones that are still here, guys? Okay, I see another question from Skip. He's asking how well AI spots proxy info for customers getting successful results with products. Yes.
Spot proxy info.
Can you clarify, maybe, Skip?
Sorry, I don't know the term proxy info.
Yeah, proxy is like that. For example, recession. A proxy for recession is, for example, lower GDP.
Okay.
So that you use another. If we don't have a clear answer to that, if we don't understand the question right now, we will follow it up.
I see what you mean. So you mean replacing a variable with a proxy info, so you still have predictive power. Well, is that the question? I think. Well, how I see it, if you have, if your data is of relatively low quality, you can have an intent to replace your data with other info. And there are multiple methods for this. For example, external sources, and it can be very helpful to use external sources to replace or extend your own data, and that can help the predictive power of your model. So the same as economic behavior. Sometimes economic behavior already accounts for a lot of the effects you see on the results on how many products are bought or sold.
All right. Skip actually immediately followed up with the question, how to know customers is getting the results they need?
Well, that depends. So that depends on how you want to take that metric into account. So you can look, for example, to if you want to analyze upsell, did the customer bought more? Is he spending more? If you analyze it in a retail way, is the customer buying more products after you took contact with them? You can also analyze it in a way that you see, normally I saw an average order value of X, and after I took actions based on my machine learning, the average order value increased with 20%. And in that way, you can measure the impact of your results.
Yeah, so maybe what we always do is a control group. So 80% goes to, for example, the churn way, 20% goes the way without having the predictive power of churn. And you can measure, of course, what has been the difference in, for example, in churn from the control group to the churn group. And because of that, so you cannot blame it at, for example, recession or whatever, because recession is in both groups. And that is the way how to measure if we are making the impact that we expect. Okay. Perfect. And that's also maybe, I think Sjoerd already explained it before, but also how are we sure that the model predicts accurate or not? So we get 24 months of data, the last 24 months, we cut off the last 4. So the last 4 actually already happened, but we don't have the data. Then we predict what is going to happen the last 4 months. And then we compare it with what actually happened. So then we know, okay, the model predicted 85% well, for example. So that is another way to be sure that what we tell is right. I think it's about time. No questions anymore. So where's the screen? So yeah, thank you everyone for being here at the webinar. We really appreciate it that you were here. If you have any other questions, please get in touch with us. That can be through LinkedIn, email, reach out. And we would also like you to join the next webinar. We will give an announcement anytime soon with a new topic. And thank you all for being here, and hope to see you next time. So that was it for today.
Thanks, everyone.
Bye-bye.